Hey guys, welcome back to another video in our routing section of this basic networking course. Today we're going to be going over dynamic routing. So static routes, as we've seen, don't scale very well with large networks. They become cumbersome and hard to maintain. Yeah, if you had to go around and input static routes on every router in your company's network, let's say you had 10, that's still 10 different devices you'd have to go around to and input these routes. And then what if one of your paths change? Now you have to go into all the routers and you've got to change all those static routes. So it's just not very practical once your network starts to get bigger. So that's where dynamic routes come into play. Dynamic routes are learned automatically by configuring router protocols such as RIP, OSPF, EIGRP, etc. If two routes exist in the same network, the one with the lower administrative distance is chosen. Administrative distance is a way that measures how good a route is through the network. So here's some different administrative distances. This isn't a comprehensive list, but here are a couple that you should be familiar with. Directly connected is going to have a distance of 0. It means that's the best route by default. Static is going to have a distance of 1. Those are routes that you input into the router yourself. EIGRP would be 90, OSPF 110, RIP 120, and unreachable 255. So the main focus of this video and in this course is going to be on OSPF. That's the main thing that the Army focuses on, and that's one of the main ones that Cisco focuses on in the CCNA. So if we go ahead and hop into our new commands, we can learn a little bit more about OSPF. So before that we do that, over here on the side I've got all these routers in a line. And I have the bottom ones all configured with OSPF, but router 3 has not been configured. So we just take a look in these. We can do a show IP route, and we can see in our routing table this router is connected to network 30 and connected to network 20, and it has learned about network 10 from OSPF. That's what the O stands for. You can look at the codes right here. And it's also learned network 40 from OSPF, which is this network down here. So now if we hop into the router that hasn't been configured with OSPF yet, we can go ahead and look at its routing table. And you can see all it knows about is network 5, that's directly connected, and network 10, that's directly connected. But if we get into global configuration mode, we can issue our first command, router OSPF plus a process ID. This will start an OSPF process on the router with that given process number. So let's go router OSPF 1. You notice that puts us into this configuration mode for that specific router process. So in this mode, we can issue the next command of network, followed by a network address, followed by a wildcard mask, followed by the word area, and then an area number. This will configure this current OSPF process to advertise the given network. We'll go over wildcard masks in a second, but for now, if we were to issue the command network 5.5.5.0 for this network that's above us, wildcard mask 0.0.0.255, we'll just say area 0 for now. By issuing this command, essentially what we're saying is we're telling our router to go ahead and advertise that it knows how to get to this network. We should advertise all directly connected networks that we want to share with the world. We should never advertise directly connected networks that might point into our company environment or that we want to keep private. So we can go ahead and advertise as well this 10.10.10.0, 0.0.0.31, area 0, and don't worry about these wildcards, we will cover them in a second. They are not too hard to understand. So with those two commands, we are now advertising the networks that we want to in this router in our OSPF process number 1. Moving on, the next command that we can issue after these come up is show IP OSPF neighbors. And if we add detail to the end of that, it'll give us more detailed information. But this essentially displays a list of other routers that have been discovered through OSPF. And another command that can be useful with just Cisco products is show CDP neighbors. You can also add detail to the end of that, and that'll display detailed information about neighboring devices discovered using Cisco Discovery Protocol. So as we see here, something's happened in our router, and it says that it's found a neighbor at this IP address. So if we go ahead and go back to privilege exec mode, we can issue this show IP OSPF neighbor, and we see we do have a neighbor, and it's this router directly below us. Now just to see visually the show CDP neighbor command, we can see that that tells us the device type that we're connected to, either a router or a switch or other Cisco devices. Now if we move on, we can also do another command called show IP OSPF database. This is going to display the current OSPF database on the device. It's useful for troubleshooting if you have an OSPF neighbor but no OSPF routes in the table. So if we go ahead and issue show IP OSPF database, we see here that we get to see all the routes that have been put in the database. Routes are generally put in the database first, and then the best route from here is chosen to be put in the routing table. Speaking of the routing table, let's go ahead and look at that again. We see now, not only do we know about our two directly connected networks of 5 and 10, but we have also learned network 20, 30, and 40 all from OSPF, because all of these routers are participating in OSPF. Some other useful commands are those such as clear IP route followed by a star or asterisk. This will clear your routing table of all non-static or non-directly connected routes and force routing protocols to request updates. And our final command for this section is clear IP OSPF process. This is going to force your device to restart its OSPF process. This can be useful if you're trying to change your router ID on your device, which is something that's used in the OSPF process to determine who is in charge of all the routers that are participating in the same area. So if we issue that command, clear IP OSPF process, we'll say yes, and we see it goes ahead and it restarts that whole process, and so now all of these links just went down, and then they've got to restart and come back up. So now that we've gone through the commands that we'll be learning, some other useful information is OSPF areas. You notice when we gave to advertise a network, we gave it an area. So in simple terms, areas are just all routers that specify the same area are going to keep their databases in sync. Generally, you don't want more than like 50 to 100 routers. There's a specific number that I can't remember, but you don't want too many routers in the same area, because then the database becomes congested and you can start to slow down the network with all the different update messages that need to travel across. Next, let's go over wildcard masks. So, like a subnet mask where we match on all the ones, essentially every one in a subnet mask is a value that can't change, and all the zeros can define the hosts that we can have in the network. In a wildcard mask, we're going to match on the zeros. So anywhere there's a 0, you can't change that part, and it has to be the same. And anywhere there's a 1, you can change that, and it can vary. The easiest way to calculate your wildcard mask is to take 255, 255, 255, 255, and subtract your subnet mask from it. That'll give you the wildcard mask. So example, if we take that all 255s and subtract a /24 from it, we would get a wildcard mask of 0.0.0.255. If we were to take the all 255s and subtract 255, 255, 255, 192 from it, we would get 0.0.0.63 as our wildcard mask. And our final example, if we had the network 10.10.10.128 with a subnet mask of 255.255.255.248, that would leave us with a wildcard of 0.0.0.7. So essentially the wildcard is specifying the addresses that are in that network. This one would specify the addresses 10.10.10.129 through 135. If you want to only match on one IP address or a host, you'd give the wildcard mask of 0.0.0.0. And if you want to match on any IP, you'd give the wildcard mask of 255.255.255.255. So that was a brief overview of dynamic routing and how we can use OSPF and some of the commands that go along with it. I hope that you'll stick around for the next video, which we will go into the lab for this section. And if you haven't already, be sure to go to the link in the description below to download this. You can attempt the lab for yourself. You can keep this for your notes. And I hope we see you in the next video.